Yes, it is working. Hopefully it'll stay working. Next thing to do is go to my OneDrive. Uh-oh. Somebody used this computer and went to fan only, fans only.
Well, wait, really?
That, yeah, I hadn't heard about that sign till that site till the news would come in to the news. Primarily porn.
Yeah, oh yeah.
Then
They,
then they were gonna shut off their, cut their noses off because they didn't want
It
to
wasn't
be
even
known as a
that.
porn site. Well, they're already known as a porn site.
Oh, yeah, well, it, primarily that's what it's for, but a bunch of groups, I mean, conservative Christian groups were trying to make their mission to like rid porn off the internet and get rid of like all of the major sites of porn or sex work primarily, because that's what OnlyFans really is. So what they were doing is they're making card companies try to disconnect from anywhere they get transactions with porn content. So OnlyFans was going to do that until they realized that's like 99% of their content, they would be out of business if they did so. So they went back on that and they're keeping it. Can only professors get into those computers?
Technically, no, I think.
I feel like I just won't believe that a professor looked that up.
Sometimes people leave thumb drives
Um,
and I don't take the thumb drives, but I plug them in and I steal all the stuff off of it and then put it back. And I've had to delete stuff because someone's had pictures on their thumb drive that they use for their schoolwork as well. So, yeah, no, that's so crazy. You know, see. It's Adobe. Let's see, what we got. Has a PDF file. I don't care. This just isn't right. This isn't the document. Howdy. Hello.
Sir, everybody's saying the review is a little bit harder than the test. Is that true?
Yeah.
I've gotten around 37 questions done on the review. Is that enough?
Say again? Close that off. Yes. Here, there we have.
Sir, I saw the exam was gonna be opened at 8 a.m. Does that mean we can start at 8 a.m.?
No, I have to change that. So it'll open at 2. Okay. We'll discuss that. Okay, that reminds me. Fixed it. Tyler, you're the only one there.
It seems somebody has dropped their mouse.
You got Okay, you sure type in put your name in chat. Like the quality of what shows up in Zoom is different room to room. The brightness of that has something to do with it. So. Okay. The exam has 10 to 15 problems. Okay. What? You're supposed to. They're not here yet.
I'll wait for them outside.
Okay. Sorry. You know what? Uh-oh. She's online. We're in the classroom. Stephanie?
I thought the test was today. No?
No, this is Thursday.
Oh dear.
Today's the review.
Okay. Does he have access to a laptop?
Does, you have a laptop?
Or he could pull me up on the phone?
Okay, he's looking at you.
Thank you.
Well, if y'all need to talk, you can get in front of the camera phone.
See if I can.
Yeah, but. So y'all can talk to each other first.
Okay, he's going to sign into Zoom through his phone.
You also have an observer.
Okay.
Oh, it's like that.
I don't know if there's an issue with her have to be in the classroom or let me bring her in.
You can see
All right, thank you.
You can see it. May I sit next to you? I know. Robert. May I sit here? I think it's okay.
She's going to pop to her schedule.
Okay, if she signs in through the Zoom link, she can see me as well.
Well, evidently it needs to be in person.
Okay, no problem.
It's my fault. I was talking with the street teacher.
Yeah, I understand a lot of people, so you're not the only one who thought that this review day was the
Okay.
exam. Yeah. So,
Sir, on Canvas, it shows the exam for tomorrow.
oh, I know why. Let me see if I can fix that as well. So let's say today's 21st, so it'd be on the 23rd, right? Let's say we're on the right day.
So I was trying to watch some of your earlier videos on YouTube.
Yeah.
So the quality is pretty bad. I feel bad for the Zoom people.
What? Yeah, because yeah. Oh, let me fix the camera.
I mean, it's still like you can make it out, but you're struggling.
Yeah. And this should be a better quality. Well, not by much. Okay. So the point of doing the review is for me to answer questions that you have about the review. So before I dive in, most of the stuff in the first part of this won't be on the test.
Well,
No. There'll be a couple of questions about this here, about converting from degrees to radians and radians to degrees.
Mhm.
But we don't do too much of this, so I don't do too much,
Yeah, we
so I don't test over it. The stuff about arc length and sector area and the linear speed and angular speed, that's more into physics and engineering. And so beyond this part of the class, we won't see it again. Some of this stuff we will see again. But this we won't see again. And the others we won't see again.
So the stuff I worked hard on, we won't see again. Not an engineer.
So which problems specifically will we not see on
Well,
test? Or like, what problems were roughly?
If you look from numbers 1 through 21, the only ones you'll see from there is numbers 10 through 15.
Okay, that's fine.
This is good to know how to do, because conversions, you're always going to have to do conversions. And so knowing how to do conversions, I consider these somewhat difficult to do, because there's more involved and more understanding to do this kind of conversion. But if you know how to do it, then it helps you in other things, not just with angles.
So, you know, the way that when I was with you in your last class, when we were taking algebra into pre-calc,
Mhm.
the way we would do the review is, you know, like you would work one from each problem that would be.
That's basically what I'm going to do today, except I'm really not going to touch on these at all.
Good, 'cause that's what I want, so you always give these great reviews.
So deciding about these angles, converting from angles to degrees to radians and radians to degrees, well, that deals with what you're going to multiply by. If you're converting from degrees to radians, that means you're putting pi into it. If you're converting from radians to degrees, you're taking pi out of it. Dividing by pi is taking pi out of it. Multiplying by pi is putting pi into it. And so these are unit fractions. Because pi radians and 180 degrees are the same angle. It's the same measure. So I have the same measure over the same measure, which is 1. So we call it a unit fraction. And multiplying by it just changes what it looks like, changes the units, but doesn't change how much it is. So a 45-degree angle is still a 45-degree angle, even if we convert it to radians. So 45 times pi over 180 is 45 over 180 times pi. And then you just reduce the fraction. Reduce the fraction. Don't get a decimal number. Don't want a decimal number. Reduce the fraction. Only they don't use the word reduce the fraction, the phrase reduce the fraction. They say simplify.
That's right.
Simplify.
I went to the STEM Center, sir. Those are some great people down there.
Yeah.
Gabriella, she's A1.
Well, I don't know them, but I know that they do good work. I've only heard good things about them. So if you multiply 45 by 4, you get 180. So that's 1 over 4 times pi. or pi over 45 radians. At this point in the game, you don't necessarily need to say the radians. You don't need to necessarily say that pi 45, pi over 4, sorry. Pi over 4 radians, you don't necessarily need to say the radians, because as soon as you say the pi, we're talking radians. But if you don't have the symbol pi in there, you have a number, then you need to tell me whether it's like 2 radians. Well, I need to know we're talking about radians. If you just say pi or 2 pi, you don't need to say radians.
Okay, so
Does that make
the other way
sense?
would be 2 pi? But
Well,
way
this
would
is
be-
not 2 pi. This is 2 radians.
Yeah.
So to find out what it is using pi is I would divide this by 3.141, whatever,
Oh, geez.
and then say that number times pi.
Okay.
And then I wouldn't have to use radians,
Understood.
but yeah.
So for number 10, you want the answer to be in pi over 4 radians format?
Well, just pi over 4.
Okay, pi over 4.
You don't need to state that it's radians. But with degrees, we always want to use a degree symbol. So 144 ends up being 144 times pi over 180, which is 144 over 180 times pi. And I simplify this fraction. And I did it piecemeal the other day. I know 12 divides both the numerator and denominator. 12 into 144 is 12, and 12 into 180, I forgot what that it was. Is that 15? No, it's not 15, is it?
What did you say? 180 divided by 12? It's 15.
It is 15, okay. All right, because 5 times 12 is 60. All right. Times pi, and then I can reduce this again by dividing out 3, and so this would be 4/5 pi, or 4 pi divided by pi. And doing the negative 180, you just do 480, you do the 480 and it's going to be negative. That's all. The negative sign doesn't affect how you do this. Multiplying and divide doesn't affect the negative sign, unless you're multiplying by a negative and then it affects the negative sign. But otherwise, the multiply is the multiply. And here we're going to multiply by 180 divided by pi, because we want to take pi out of it. Pi's go to 1, 180 becomes 90. So this is 5 times 90, which is a negative 450 degrees. Which is once around in the clockwise direction and then going another 100 and what? No, another.
So if I go around that a different way, but I still come to the same answer, is that okay?
If you work it differently than I'm doing here, that's fine. As long as I can follow your work. Understand? So if I can see what you're doing and it's correct, then I have no problem. That brings up a point that there are some professors who say my way or the highway. I'm not one of those guys.
That's why we love you, sir.
right, so I know, what is one's, pi 6? How many degrees is that? It's the first quadrant degree. What is it?
30.
30. So a negative pi over 6 is what? Negative 30. That's a negative. You didn't have to calculate that one. Well, this one here, I can simplify this before I do any multiplying. I can divide both of these by 3, so that's 3 pi over 2. Right? I simplify that. And so what is that in degrees? 3 pi over 2 is one of the, it's one of the coordinate angles of the quadrantial angles. So that's 270 degrees. I'll give you one that's easy. But if you multiply by a 180 over 6, you'll get 270. Because 6 into 180 is 30, and 30 times 9 is 270. All right. Come down here. Okay. In ACES, hopefully I posted it in for this class. In ACES, no, in Canvas, under files, in handouts, there is a large single page PDF that says blank unit circle. That's the title of the document. Blank unit circle. And it has all the angles we discussed in this class posted. All right, these lines here on the document are dotted lines. Okay, but it shows the 45-degree angles, the 30-degree angles, and the 60-degree angles.
Yeah, I got it, sir.
Here, yeah.
It's right here. Here it is, people.
Yeah.
Blank as ever, but.
No, not that one.
Sir. The front.
Oh, it is that one.
Yeah.
But the other side comes from a different document, right?
I think you have like 2 of them posted. This just had this, so I was like, hey, I'll take
Oh,
it.
it did? Okay, I didn't realize that. Okay, well, you're gonna get that on the test. I want you to fill out that circle. So one of the, I think it's the first question on the test, as a matter of fact. It has this circle showing there, and it has the little, it has, let me see that, 'cause I can't remember where the squares are. Okay. So it has the little ovals here on each of these. And then it has little squares on here. And so in those ovals and in those rectangle, those squares, you put the angle measure. You choose whether you put the radians here or the radians here. I don't care.
Yeah.
So your radians go in one and your degrees go in the other. So you name all the angles, name all the angles using degrees and radians. And then outside here, because this is a unit circle, the points on the outside here have specific values that we've done. And so you fill those in. That problem is worth 32 points.
Oh, nice.
Well, because, no, not 32, 16. 16 points. Because you have 1, 2, 3, 4 pieces of information put in for each angle. And each, oh no. Oh no, it's more than that.
Oh, yes.
because it's gonna be 4 and 4 and 4, and so that's 16 times 4, which is 64. No, I'm not gonna make this for 64 points.
I
Wow,
know.
so that-
I'm sorry, I'm not gonna do
I
that. So the 16 points will work.
At least times two.
And that'll be 4 points for each quadrant. So 1 point for each angle done correctly.
Sir, I would bet 64 points on a memory game of a circle. I would.
Sure, do it, do it, do it.
No,
It's
I
just
already set it up, so I'm not gonna change it. So how I look at the grading is different. So if like this is the 30-degree angle, so it's pi over 6, 30 degrees, and then square root of 3 over 2, 1/2. So if you got all of those correct, you get a point for that point. So I just go through and look at it, see where it's wrong, and take off the points accordingly. So that's what all of these are dealing with. Okay, so I'm not going to ask for individual angle values, cosine, sine, secant, and cosecant, and all those. Okay. So just knowing that, memorizing it, knowing it, or you don't necessarily have to memorize it. All you really need to know is this first quadrant here, from 0 degrees to pi over 2, what all those values are, and then everything else is built off of that. So. $405. Where does that wind up? Well, going around once is 360. So what does that leave? So if I use the 360 degrees, what's left over?
45.
45?
Oh, what's left over?
Yeah.
To get to 4 or 5?
Yeah.
45.
I subtract, right?
Uh-huh.
Negative 45?
So that's gonna be 5. Yeah, so that is 45. So it's gonna come. So this is where it ends up. Right?
Yes.
We go around once, which is 2 pi or 360. So we used up 360 of this already. What's left over? 45 degrees.
So which one are you on?
Number 37.
Oh, we skipped 22 through whatever?
Well, yeah, because that's just the unit circle.
Oh, okay, understood.
So we don't need to use a calculator on these because we're just gonna find what is that with sine of 45 degrees.
Oh, this is unit circle.
Is the same, yeah. Is the same as the cosine of 45 degrees, which is what?
Pi over 4. Is that what you're looking for?
No, I'm looking for the sine of 45.
Oh,
The sine of pi over 4.
is square root of 2 over 2.
Right, so this is the square root of 2 over 2. Cosecant, well, that I'm gonna look for sine and then do the reciprocal. Right, because cosecant of theta is 1 over sine of theta, which is the reciprocal of sine. So I need to find out what's my smallest angle that we're talking about here. All right, 360 is once around. 720 is twice around. And so if I take 720 away from 360, I mean, from 960, that leaves what, 140?
240.
240 degrees. So for that one, you're gonna go around twice, and then you're gonna go another 240 degrees.
Yes.
What angle is that? So that angle corresponds to what angle over here in the first quadrant?
Oh, okay. And 240 corresponding to 60 degrees is the opposite.
Oh, I didn't go far enough then. That was 210 I went to.
Corresponding to 60 degrees.
And so what sine of 60 degrees?
3 squared over 2.
So, and sine is negative down here.
Uh-huh.
So it's going to be negative
3 square root of 2.
square root of 3 over 2, but it's the reciprocal of that. So we have the negative of 2 over the square root of 3. Simplifying rationalize my denominator, I get the negative 2 square roots of 3 divided by 3. Now, the issue becomes, how do you type this into the computer screen? Because in Canvas, for this, it doesn't have all the fancy little bells and whistles that MyLab has. So it won't have the little square root symbol and the fraction deal to be able to write those. Well, then you write the -2 and then put parentheses and then square root, another parentheses, 3, and then a fraction bar or a divide, and then 3.
So you needed a whole constant to put it in.
Or you can write it out in words, -2 square roots of 3 divided by 2. Divided by 3.
And you'll go back to the notes, to the work and check it out anyways to make sure
Yeah.
so you'll be able to see it.
This is what you type in.
Yeah.
You do all your work on paper that is going to be submitted. And I'll tell you how to do that in a moment. Or towards the end of the class. Okay. So we look to find the reference angle here. And in this case, what I mean by the reference angle is an angle that is less than 2 pi. That it corresponds with.
So when will this video be uploaded?
As soon, well, pretty soon after I get home from class.
Great. Great, thank you, sir. Sir, is Esteban on there?
What?
Is Esteban on there?
Who?
Esteban?
I don't think so.
Oh, he's MIA, sir.
Oh. All right, yeah, this is dealing with the unit circling. And so is this, and I'm not doing those types of things on this test. Now, I think there's a problem or two like 34 and 35. And that's just cotangent to 45 degrees. Well, the 45-degree angles, tangent and cotangent are both either 1 or -1.
Yes.
And so this is in the first quadrant, so that's a +1. And sine in the first quadrant is square root of 2, a positive square root of 2 over 2. So we're subtracting the square root of 2 over 2. So I want denominators to be the same. So we have 2 over 2 minus the square root of 2 over 2 equals 2 minus the square root of 2 over 2. And this is the answer.
Okay, that's one that we'll have to format in that way that you
Yeah.
just did over there.
Or you can just write this and then say divided and use the word divided, the words divided by 2.
They do divide with that forward leaning slash.
Yeah. You could do it, or you could write it this way too, because I'm gonna put parentheses around the entire thing. Because the entire thing is being divided by 2 and minus square root of 2.
Oh, okay, then everything divided by 2, gotcha.
And the TI calculators used to, when you did square root, it didn't have the symbol, it used the phrase square root 2 and then had the parentheses. In the dark ages,
The good old times, sir.
the first time I came across it, well, when I first started teaching is when I came across the TI 82, which was brand new at the time. And that was in 91.
Oh, sorry, I've been seeing a lot of those C4 billboards. So I see how you could have seen one.
Yeah, that's how I learned about it, was I saw a billboard. And then at the one of the ATVs I shot at, it was in there. So I just gave it a try.
And you like those better, the reins?
No, it's just the flavor is different, that's all. But I think that one does give me a little bit more of it, Joel,
I like that, sir.
because I was drinking one during my 8 o'clock class today. And I noticed I was talking faster than I normally do. Okay.
Are your students noticing?
And
sir?
I was a little bit more energetic up here in front of the class, so. Where was I?
We hit just on 34.
And that's how 34 and those 3 are done. So I'm not gonna do all 3 of them. Now, 41 through 44 will not be questions by themselves on the test. How you do numbers 41 through 44 on the test is like numbers 45 through 45 through 47, 48. Yeah, it's in the graphing.
Okay, so they won't be.
Because you have to find the amplitude, you have to use the amplitude, and you use the period to be able to graph.
Yes.
So that's where it's gonna be asked, here, not here.
Okay.
Reviews are for practice.
Yes.
So I asked you more questions than you're gonna have on the test. And there's between 10 and 15 questions on the test. Yeah. Although some of the questions are like these are involved.
How many graphing questions will there be?
At least 2 that I can think of.
Will they be like, what's equation?
They'll be just like what we're doing here.
Oh, okay.
Yeah, one of them's a little more trickier than you've seen in the class.
Sir, you
But-
said you wouldn't do that.
Well, I know, I don't usually do that, but this is pre-calc.
Uh-huh.
All right, in calculus, I do that all the time,
Oh, gosh.
because you're supposed to be starting to think ahead and anticipate and extrapolate forward, not just spit back what I said. Yeah, I had professors in Cal, one of my professors, we had to do a proof. We had to prove things, so that's more than just spit back what he tells us in class. So that's using what he tells us to come up with a way of, okay, I start with this, how do I get to this? That's what trig identities are. I start with this, how do I get to that? It's a proof. It's proving that this does equal that.
I mean, we do that essentially in our work that you do.
Mhm. Yeah, solving equations is a proof without the reasons.
Yes.
Okay. If you put the reasons why you can say each step of the way, then it's a formal proof. So, unless you want me to do one of these,
Oh, yes, please, sir.
I'm just gonna go on. Okay, which one?
Oh, 40. Well, which one do you think? sir?
I don't care.
Okay, 42.
All of
42. No, well, I do all of them. All right.
Can you do
So
42
it's
more times?
asking for the amplitude. What's the amplitude on 42?
Oh, the app is 5.
5. It's the absolute value of 5, which is 5, all right? The amplitude is the absolute value of A. A is 5. So what's the amplitude on 41? I said I wasn't going to do them all.
2.
The amplitude is 2 because amplitude is positive. A can be negative, but the amplitude is positive. So here the amplitude is 2.
Yes.
But in changing our key values, our key points, we would multiply by -2. Because multiplying by -2 changes our maximum to a minimum and a minimum to a maximum. And so how do you find the period for sine and cosine? What's that formula? Period, which they use the letter T for period. What's
Oh.
that formula?
Oh, that's an. Oh, yeah. Nothing.
Does anybody remember? It should be reside in your head.
Oh, it should?
Yes,
Jesus.
this is not a formula I give you.
Oh.
There are formulas I give you. This is not one of them.
T equals 2 squared.
No. 2 pi over omega.
Oh, that's one you made, right? Yeah, maybe. T equals 2 pi over omega.
Okay. What's omega?
Oh, omega is 5. I mean, sorry, I was looking at 43.
Yeah, 43 pi. Omega is 5. What is omega in number 44?
1/4.
1/4. What is omega in 42?
4.
4. What is it in 41?
1.
1. We're always multiplying by 1. So if there's no number there, then it's 1.
Yes.
Just like we're always adding 0. If nothing's being added, then we're adding 0. So the period here is 2 pi divided by 1/4, which is 4 times 2 pi. So the period on this is 8 pi. So on the graphing, you can't post the graphing online. You can only do the graphing on your paper.
Yes.
But on the test, you'll be given an equation and it'll show a graph. But the graph it shows won't have it won't have these. It won't have those. Because I think it's stupid that they make it the marks along there in pi, because the period here, you won't have pi the symbol pi. They'll be in radians, but you won't have the symbol pi there. So we need to determine what A is, so we can find out what the amplitude is. What is A?
2,
2. So the amplitude is
2.
2. What's omega?
It's like pi, sir.
Yeah, it's pi. And so the period is
It's 2 pi over pi,
2 pi over pi, which is
2.
2, which is why I don't like the fact that they had put these pi here. Pi is 3.14. So 2 is all the way back to here. And so we're looking at the period being in here. That's why on the test that's being, the graph that's posted in the test doesn't have these marks assigned a value. Okay. So you just decide where your period goes from 0 to 2. That's the initial period. So you decide where 2 is. All right, you're going to need to divide it into 4 sections. Okay, because you have 5 key points. So I'm going to come out to here for 2. And so this is 1. And oh, wait a second. I didn't went out too far. Yeah, I did. Okay, so I'm going to call this 2.
Oh, yeah.
And so this is 1, and this is 1/2, and this is going to be 3/2.
Yes.
And so those are my initial values, my x values. My x values for sine are 0, 0. So you look at the unit circle you just made on the first problem, and you look at where those key points are, the cardinal points at 0, at pi over 2, at pi, at I'm going to run into this, at 3/2 pi, and at 2 pi. These are the 5 key values, the 5 key points for sine.
Yes,
For the first period.
We'll use these throughout all of the,
Well, for sine,
okay, yes.
and then you change it appropriately. Now my x values, well, the 0 stays 0, but instead of saying pi halves, I say 1. So 0, 0 doesn't change, but this becomes 1/2, 1, and this becomes 1, 0. And this becomes 3/2, -1. And this becomes 2, 0.
So how many points would the 2 graph questions be worth, like total?
Shouldn't that be
10
2, not 1,
Where?
10 points.
for the y? Shouldn't it be 2
On which one?
for the amp?
Where are you talking about?
For the amplitude there. I thought you said it should have equaled
I
2.
haven't done the amplitude yet. All I've done was change my x values from 0, pi over 2, pi, 3 pi over 2, and 2 pi to 0, 1/2, 1, 3/2, and 2.
Sir, we have not done the amplitude for this equation yet.
I haven't done the amplitude yet. All I did was change the period.
Oh, okay, you haven't changed the numbers according to the amplitude.
Right.
Okay,
I haven't applied the amplitude yet.
okay.
Now I'm going to multiply each of the y values by the amplitude, which is or by A, which is 2. So now now I change them. Well, if you want to do it all in one step, that's perfectly fine by me.
Yeah.
So now I have 0, 0, and 1/2, 2, because I'm multiplying each of the y values here by 2. So this just changed from, my first step is to change my x value.
So you changed them by just taking out the pi, right?
Well, I changed them by looking at what happened to my period,
Which is 2.
which is 0 to 2. And now I have my 4 sections inside. And so my x values now got changed
So why, how?
by dividing 2 pi by pi gave me a period of 2, and halfway is 1. And then the 2 quarters are 1/2 and 3/8.
So can you translate that? How did you translate that over to the points? The second.
Well-
the second one.
This point got moved to here, so it didn't move at all.
Uh-huh.
This point got moved to here.
Okay, where on the graph did that happen?
All right, so for this graph, all right, so 2 pi halves is here. And so I'm going to say that I'm going to do this is 1. And this is 2. So this point got moved over to here. And this point got moved over to here.
So why?
Just a second. Yeah, because now this. Wait a second. This is 2 pi and this is pi. So it comes up like this. Winds up back here. So this is, where's pi? At pi it's 0, right? And so, okay. So it goes like this. At 1/2 a pi, okay. At 1/2 a pi, it's here. And then at pi, it's back here. And at 3/2 pi, it's back down to here. And then it comes up to here. So this is the first period.
Yes.
And we're changing our x values towards the y-axis. So all these points get shoved this way. All right. This x value at pi halves gets shoved back to 1/2. This value at pi gets moved back to 1. This value at 3/2 pi gets moved back to 3/2. And this value, so this point got moved back there, and this point got moved back to 2, which is back here somewhere. So everything got shoved this way. Appropriate,
And that's because you changed what?
because the x values changed,
Right.
because my period changed. My period got squashed. It shrunk. And then the next thing is it gets elongated, it gets pulled away from the y-axis. So instead of going up to 1, that goes up to 2. And instead of coming down to -1, it comes down to -2.
Okay, where did you get that 2 from? That elongated it.
This.
Oh, okay. So you're doing, okay, so that part I understand, because that's very simple. You just multiply the y by 2.
Right.
What did you multiply the x by?
I didn't multiply the x by anything. I changed, well, I did.
Yeah.
I divide each one of these by pi. And that's what I got here, 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 and here.
Yeah.
I changed, that's what I did when I changed my period from 2 pi to 2. So instead of going from here to here, now it goes from here to here. And so instead of going to pi, it goes to 1 in here. Instead of going into pi over 2, now it goes to 1/2. And instead of going to 3 pi over 2, it goes to 2/3, to 3/2. So this whole thing got shoved this way. So it's like you have a spring that you push together. The highs and lows remain the same,
Yes.
but now they're closer together. I'm increasing the frequency. If they were sound waves, it would go from a low hum to a high hum
Yes.
or a
Yes.
higher hum.
Yeah, and you got that answer by dividing by pi.
I divided by pi, and instead of going through and dividing each one of these by pi, I just determined what the period was and then found those other key values.
So in order to get the x, we divide by a period.
Right. Gotcha. Okay. Know what I've been saying?
Well, yeah, but my ears, you know.
Well, you divide by omega. Well, yeah. So I'm dividing each angle by omega. I'm not dividing by the period, I'm dividing by omega.
Okay.
So 0 divided by 0, 0, 2 pi, pi over 2 divided by pi is 1/2. Pi divided by pi is 1. 3/2 pi divided by pi is 3/2. 2 pi divided by pi is 2.
Okay, so
But I did that dividing by only dividing 2 pi and then finding those other 3 points in there. Because they're halves. Actually, they're quarters. So each one of these is 1/4. So I go a half and then I go a half again, and then I go a half between those.
I was just getting caught up on the x values, but you said that you just divide by the omega.
Yeah, you just change your period and then you redivide
Okay, it's a 4 portions.
into 4 portions. Right. Okay. And then you just multiply each of these y values by what the function is being multiplied by. And so we plot those points. So 0, 0, 1/2, 2. And then 0, and then 3/2, -2, and then 0. And so the first quarter goes like that. Coming back up again. And so, and extend it out a half a period on either side.
Sir, I think I got it.
Okay.
Okay. So we went from 2 pi to pi, and then we just cut up into 4.
Right. You don't have to, because sometimes it's easy, it actually easier it's to do it that way and then just replace these numbers with the new numbers. Because that's the same as dividing by omega. Okay. Okay. I meant to ask, were there any more questions before I erased all that? Okay, so I'm going to do -4 cosine.
So bad that you're still on mine, y'all. Come on.
All right, now cosine, now my key points for cosine are different than my key points for sine. Because when the angle is 0, the cosine is 1. So at 0, we're at 1. And so that means at pi over 2, we're at 0. And so that means at pi, right, if you go back to the unit circle, so that's these 4 points here, and that's the x value of those 4 points. So at pi over 2, the x is 0. At pi, the x is -1. And at 3/2 pi, it's 0 again. And at 2 pi, we're back to 1. So that would look like this. So it would go here, 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 and back to here, and up to here. So in the first period, it would look like that. Kind of. Be a smoother curve than what I drew. All right. Now we figure out the period. What's the period in this case? What does t equal?
Negative pi over 4, negative 2 pi, negative pi over 2.
Nope.
Oh, I tried. Oh, sir, t
The
equals-
negative sign deals with the amplitude.
Oh, so we're not using negative signs.
We don't use a negative sign here,
Okay, so negative.
except when we start changing our y value.
Heard.
This is what we change our y value with,
Oh, our omega is 1.
because this is our y value, and then we multiply it by -4.
Our t is 2 pi over omega, and omega is 1, so it's 2 pi.
What do you mean? What do you mean omega's 1?
I mean, omega is pi. Okay, so it's 2.
So it's 2 again.
Yeah.
So now we come back again to 2, which is here. Get it to color. So we come back to 2, which is about here. And halfway for 2 is about here. So that's 1. And so over here we have 1/2, and over here somewhere we have 3/2. Not drawn to scale because pi. Okay. So what this did, it squished all these this way. So this point came all the way back to here. This point came all the way back to here. This point came all the way back to here. And this point comes all the way back to here. So now, just changing the period makes it look like this. Everything got squished towards the y-axis. Now we're going to change the amplitude. Right? We're going to change our y values by multiplying by the -4. Although the amplitude in this case is a +4, we multiply by the -4 to tell us how high we're going to go and how low we're going to go. So I changed all these values, the x values here. This is stayed 0, 1. This one became 1/2, 0. This one became 1, -1. This one became 3/2, 0. And this one became 2, 1. Now, the next thing we do there's a purple.
Sorry, is it not a rule to just take out the pi? Because I'm seeing a trend here where we just take out the pi.
No, we don't always take out the pi. We are taking out the pi in this case because we're dividing by pi.
Okay.
I'm going to do the next one as well because we're not going to be dividing by pi.
Understood. Thank you, sir.
Now, if I realized that, I would have changed this. So now we're multiplying the y values by a -4. So 4 times 1
Yeah, I think before, yeah.
gives us a -4. 4 times 0 is still 0. 4 times a -1, -4 times a -1
Oh,
is +4. -4 times 0 is still 0. -4 times 1 is a -4. So what used to be our maximum values are now our minimum values, and our minimum value became our maximum value. So this point went down to here. The 0 stayed at 0. This point went up to here. Yeah, okay. And this point stayed here. And now this point went down to here. So now we have this lovely thing. The frequency remained the same, but now what is that? Pitch? Now I'm starting to understand the stuff from physics that I taught in high school,
If it's a long.
which I had no business teaching physics.
It's like a low road if it's a long.
Because it takes it longer for each wave to
To
hit
reach
you.
your ears. Yeah.
So that's a blue shift.
And I'm like, shoot, I
Would
didn't
be-
even know I knew that.
So this shows a red shift. If we're talking sound and light. Okay. Questions on this? Yeah. All that work all in a second. Okay. Oh, there's two. Oh, I'm not gonna look at 44. I mean 48. This one, our omega, oh, he's out of the room. So we always want to identify what A and alpha are. So A is 2 here, and that's what we multiply. So this is what we multiply. I can write the word. Multiply the y values by. And omega, in this case, is 4, and that's what we're dividing the x values by. So we multiply the y values by what the sine is being multiplied or by, or the cosine is being multiplied by. And we divide each of the x values by omega. Well, instead of dividing each of them by omega, we do the 2 pi divided by 4, which is pi halves. So our period is now pi halves. So here we have 0, and now here we have pi halves. Okay, so dividing by the 4, this one is even more severe than the other one. Because now we're talking about, instead of our period going from here to here, now our period goes from here to here. And so now I cut this into 4 of 4 equivalent sections. So I do halfway, so half of 1/2 times pi over 2 is pi over 4. And then halfway down again is pi over 8. And then I go another pi over 8 this way, which is 3 pi over 8. So for sine, now my x values are these 3 numbers. So we originally have 0, 0, pi over 2, 0, pi over 2, 1, pi, 0, 3/2 pi, -1, and then 2 pi, 0. And so now 0 stayed 0. And now 1/2 becomes 1/8 pi. And pi becomes pi over 4. Right? If I divide pi by 4, I get pi over 4. And the y value hasn't changed yet. So 3/2 pi becomes 3/8 pi. Right? Dividing 3 pi over 2 by 4 is the same as multiplying 3/2 pi by 1/4. And so we get the same number. It's just, I think that way is much easier. It's taken me a lot of years to figure that out myself. And so now 2 pi becomes the pi over 2. And I didn't change the y values yet. Now I multiply by the 2 out here. Okay. And our amplitude is the same thing too. And so I multiply each of my y values by 2 again. I don't know, they like 2 a lot. The zeros didn't change, but my maximum value and my minimum value went up to 2 and down to -2. So now this point stayed here, this point went all the way up to here. This point's at 0, this point comes all the way down to here, and then it's back here again. So, yeah. And then you would continue it on at least half a period on either side. So you go to another 4 pi, a negative pi over 4, and then you come up here to 3 pi over 4 with 5 pi over 4, 5 pi over 8 in the middle with a -1/8 pi over here, and then a -1/4 pi. So the original one, go from, this is pi, this is 2 pi, so that would be this here. This would be the original sign goes like this. And so it's got squeezed back to here and pulled apart. I'll tell you the truth, I don't think I put any of those on there. The last ones, like 49 and 50, I don't think I put any of those on there. That's where you have to figure out what the period is, Well, first you figure out which function you're dealing with, the sine or cosine. And number 50, it'd be cosine, and it'd be 5 times cosine. And then we just need to figure out what the period is so we can figure out what omega is. And I consider these graphs incomplete because they don't show, well, this does show a complete period here. From -2 pi to 2 pi, so that means the period is 4 pi. So 4 pi equals the 2 pi divided by omega, which means omega is 1/2. If omega is a positive number less than 1, then that's a stretch, horizontal stretch. If omega is a number greater than 1, then it's going to be a compression, like all the other ones we've done. I don't think we did one where it was a stretch.
So you're saying there's none like 49 and 50 on the tests?
I don't think so, because I didn't like, when I was creating it, I didn't like the examples they give.
So should we be concerned with reviewing those for the test?
I don't want to say a thing and say, and then find out I did something different. No, there's nothing like 49 and 50 on the test. And there are exactly 12 questions on the test.
Wow.
Well,
Have we gone over one from each of the
there's a
12?
dozen.
We have, okay, great.
We've covered it. If you, and if you don't have any problems, any real problems with the review, you shouldn't have any problems on the test.
Did we go over one similar to that one you said maybe a little tricky?
That's too light. So if we have y equals 3/4 cosine of 7/3 x. Yeah, what the fuck, right? Okay. Well, you do it just like we did those. Right? The period is 2 pi over omega. So this is 2 pi being divided by the fraction 7/3. Whenever you're dividing by a fraction, you multiply by its reciprocal, 3/7. So this is 6/7 pi. So I would, my number line would go from 0 to 6/7 pi. Halfway is 3/7 pi. And then halfway again, well, I just multiply that by 1/2, so that's going to be 3/14 pi. And so I'm going to add 3/14 to 3/7, so that's 3/14 to 6/14, which is 3 and 6 is 9, right? So that's going to be 9 pi over 14. So that's the trickiest part here, is figuring out those numbers. So now with sign, my key values are now 0, 0, that didn't change. And then, let me write it down lower. 0, 0, and then 3 pi 14ths, 1, and then 3 7ths pi 0, and then 9 pi 14ths, -1, and then 6 pi for 7, 0. And now I multiply the amplitude, where did I write it? Right here.
Uh-huh.
A is 3/4. So now I multiply each the y values by 3/4. So I'm squishing it towards the y, towards the x-axis. So 0, 0 stayed 0, 0. And this becomes 3 pi over 4, 3/4. And this becomes 3 pi over 7, 0, because the 0 is not going to change. 9 pi over 14. And this -1 becomes a -3/4. And 6 7ths pi 0 doesn't change. Okay. And then as far as graphing these points, you have a graph, and you just put like this, you just put those values there, and then here's 1, so 3/4 is there, and 1 is, say 1 is down here, so this is a -3/4, and that's where this point is going to be. And so these are all at 0, and so there we have it. So it's been squished this way because I'm multiplying by a fraction greater than 1, so that means it's going to be a compression.
Oh, okay.
Actually, I have one on there that is going to be a stretch.
I'll be done with those, sir.
Well, it works out the same way.
Yeah.
So instead of being 3/7, what if it was 5/9? And so instead of multiplying by we're dividing by 5/9, so that's the same as multiplying 9/5. So 2 pi times 9/5, which is 18 pi over 5. And then I just take half, and then I take half again, and then I add that half to get between. Now, these are odd, these are weird fractions I threw at you, so I took more care in the fractions I use. They'll be easier to use. Because I know everybody loves fractions. But my viewpoint, you need to get comfortable with fractions. If you're going to continue on in mathematics, you need to be very comfortable with dealing with fractions. Because the more comfortable you are dealing with fractions, the more you understand fractions, the easier math is. Because the skills and understanding the fractions apply. Because it's looking at what you have, what are the rules for changing it? And so I change things appropriately. That's all we do in mathematics, is we look at what we have and look at the rules to change it, and how do we change it so we get to where we need to go. That's problem solving. That's what you do in life. You look at what you have and what you can use in that situation so you can get to where you need to be.
Sir, gosh. Please, I'm gonna start writing this stuff down. Stop.
Yeah, so freshmen, 14-year-olds who ask me, well, when the hell are we ever going to use this? Well, they quit asking that question off the book.
Yeah.
Because, yeah, are you going to use out the skills, the specific skills from algebra for the rest of your life? Probably not. Unless you're in a career that uses it. But the problem-solving skills that you use in mathematics, you use in life. And so it's a matter of organizing your thoughts, organizing your material, so you can put it together in the way you need to, where you need to be.
I can name it.
And these aren't my thoughts alone. So, you know, it's just something that I've been taught and I've learned over the years. Okay, now scroll down a little bit because some explanations need to happen. Or the test. Which one way? Oh, there's not a big blank spot. There it is. Okay. So on Thursday, the test is in Canvas.
Oh, sir.
You do not need to come to the classroom, for those of you who are in the classroom. You can do this at home, you can do this at a library or someplace where you have a certain amount of privacy so you can do the test without being interrupted. You get into Zoom, this you have to do. All right, I will void your test if you do not get into the Zoom and get on video. I need to see your face, and more than just your face, so I know a lot of people like to get on video, and so they say they're on video, they're on the Zoom, and all you see is this part of their head and the wall behind them. Okay, no, I need to see what you're doing in front of you. So you position it. One way to do this is to get on Zoom if you have a cell phone or a tablet that you can get into Zoom with, and have it off to the side so it shows you working. That would be ideal. And then the computer's there to present all the word problems, all the problems that you write down. You write them down and work them out on paper. Okay? So once you get into Zoom and you're on video, then you go back to the Canvas and you click on quizzes. It's already there. And there's exam 1 in there, but it won't let you in until 2 o'clock on Thursday. And then you get in there and you start working it. On ones that you work to a single number answer or some kind of an answer, you post those you post them for the answer and for that particular problem. On the ones that like the one with the unit circle and the ones you graph, well, there's nothing to post, so you don't have to put anything there. Because when you're done, I didn't tell this to the other classes, but when you're done, there's under assignments, it's there now. There's work for exams. And under there's already exam 1. All that is there is to submit your work. So after you're done, you take a picture of your work. How you take the picture, I don't care, but you save it as a PDF file. PDF. File is redundant. You save it as a PDF. It took me about 2 years to realize I was being redundant when I said PDF file. Because that's what the F is file. Okay, I'll shut up about that. Now, how do you get it into, all right, if you have a cell phone, there's an application called Adobe Scan. It's free from Adobe. And all you do is you focus on your work and you hit to take the picture, and then you go to the next page, take the picture until you've taken a picture of all your work. And then you tell it to save it as a PDF file. And then that's what you're going to upload. When you get into exam, you're going to upload a PDF file, and it will only let you upload a PDF file. It won't allow anything else but a PDF file. If you do not have a program, or you can't use Adobe Scanner or something similar, you take a picture and then you put them into a Word document or some kind of a Word document and save it as a PDF file. That's what I've had some students do, because they had to take a picture from a document camera and not from their phone. And so there are ways to create a PDF without using the Adobe Scan. I know people have told me in the past that iPhone has something that is like Adobe Scan. So you can use that if you have an iPhone, or you can download that on your phone. That's extremely, I can use it without even, I could use it the first time I came across it. So that's how easy it is to use.
Yeah, I still use it, sir. Even like,
Okay.
not in your class, I
One-
use it sometimes.
Yeah. Once you upload it, then you hit submit.
So,
Please be sure that the PDF contains everything, all of your work. So if you you can upload them as individual files, but please be aware that sometimes I don't get those. I don't get them all, or they show up in a way that I can't see them. That happened last semester to one student, and so they had to go back and rescan everything into one file and then re-upload it. So that was a hassle for them and for me.
yeah, it happened to me between you and me, sir, sometime.
Oh, it was?
Yeah, well, not that, I don't know if that specific example was me, but yeah, you were like, hey, it didn't come through or something, I had to send it a different way. And
Okay. Oh, yeah, you had me last semester. I forgot.
Sorry,
I keep
come
forgetting.
on.
I'm sorry. I keep forgetting.
I always talk about it, and I was like, yeah, sir. last
I
time you
know,
were back,
I know
sir, I had
you
to
do.
not, sir."
Yeah, okay. So getting the work to me is extremely important, because when you get into here and it tells you, and when you get into exam, and I've posted the instructions to the exam in announcements. It says, if you do not send it this way, if you just try and send me the videos, or I mean the pictures, I will not grade them. Because one reason I want it as a PDF file is I can grade them on my computer, and I can write and make notes on them and send them back to you. And I figured that'd be a great amount of help for you as well as helping me grade things easier. I grade everything on a rubric. There's some exceptions, like the unit circle. That's not our rubric, it's either there or not. So the rubric is based on correct answers and the amount of, and the quality of your work. There's nothing on there about neatness, tidiness, and organization. There are some professors, that's a big deal for them as well, neatness, orderliness, and organization. I prefer it if you would be neat and orderly, but yeah, you've seen me all over the board. Okay, any questions? Everybody good? You can go away. Unless you have questions, you're free to go.
Thanks, sir.
All right. Jump out of Zoom as soon as I turn that off. And Stephanie, we'll see you later.